All right. Well, welcome all to the last workshop in the non-visual data science workshop series. If I can manage to get myself framed. Um, my name is Patrick Smith. I am the chief learner at IOTA, and so this is the last workshop in our non-visual data science workshop series. So workshop number 5. It's our second workshop on sonification. And Sarah Kane is going to be, leading us in a little further exploration of making data representations with sound rather than sight. And I just want to go through a few administrative items, and then we'll get started. So I'm in the final stages here. I'm waiting just to hear about something about the server setup, but we're going to have a mailing list set up for people getting started with data science with a visual impairment. So I'm going to send out an email when that's all set up. You'll see that in an email that will go out. Hopefully, I'll have it done by the recording email that will go out tomorrow, most likely. But if not, it'll be later in the week. It'll be its own separate email. We also have a couple of events coming up that I'd like to kind of highlight to you. So I'd recommend keeping an eye on the email following this. But one, for example, is Tony Fast, who's been coming to these workshops and is doing an event with Space Telescope Science Institute related to basically the topics that we're doing here. He's developing a accessible version of Jupyter notebooks, and maybe an interesting time to, if you're interested in that, it sounds good. He may need some testers and so on in the coming weeks and months to try out his prototype. So, and the usual. I just like to thank a couple of people. Our helpers are in the room. So we have Elizabeth and Alex in the room today. I will also be here helping out. So if you have any questions, just drop them in the chat, and one of us will respond to you. You can either message myself, Patrick Smith, Alex Ogden, or Elizabeth Sola privately if you'd prefer, or you can just ask your question publicly, and we'll manage it that way. I'd also like to thank Pandas and NumFocus for hosting these workshops, and especially Patrick Hofler, who's a Pandas core developer, who sort of helped us put this series together. And finally, there's one small sort of technical item that a couple of people have emailed me about, one specific thing. So in the second and third workshops, we learned how to, maybe even as far back as the first, we learned how to use the IPython magic commands save, so %save and %load. And so people not really having so much trouble with the save command, but then when they were loading their files, there was some difficulty with the behavior that is experienced when you load. So the part that I think I didn't explain, and I'm going to update the tutorial. We have an issue open, so I will not forget that. But the extra step that we sort of left out is that when you do the %load and the file name to load in your code, then once that successfully executes, what it basically does is it kind of like almost like types in all the code. So it's in a giant block in IPython. And in order to run that giant block, you may hear different things. You may hear the code that you imported. You may hear ... That's what some people were hearing. But basically, in order to sort of complete the loading process, you need to hit the enter button twice. Okay. And once that happens, it basically is as if you typed in all of that code yourself, and it runs each line separately. And once that's done, you can, if you want, you can clear the terminal, and with Control L, and then you should have a nice clear session with all the variables and so on available to you that you had before. And there's also some people were asking about how to store specific variables and so on for next time. So, for example, if you want to store a data frame, and for that, I would take a look at the %store magic command. So essentially, you could do a %store and the name of a variable, and it will save it for you to load it in a future session. And I think it's %store R -R or something like that will allow you to load variables. So that's something people seem to have a lot of interest in. So, and a few people are emailing about it, so I thought I'd cover it. All right. So I think that's everything administratively. And of course, I guess I'll maybe spiel a little bit now, since I think people are most engaged right at the beginning. And so I'll just say, I'll also say this at the end, but these workshops, it's been a real privilege to put together these workshops. We will be creating a website specifically for the curriculum, so it won't always be on GitHub. Once it kind of stabilizes, once it's all finished, we'll move it to its own website. And I would ideally like to, turn it into a larger resource with some of the suggestions and so on that have been provided. And of course, this is, we had 10 hours with you. We covered a certain amount of material, but obviously there's a lot to data science. There's a lot more to possibly cover. And so, I hope to do more with these materials, but there will be, at the very least, what we've done so far will be available in a sort of a website resource. When that is available, I will send out an email about that. And I mean, I would also say, if we're all part of the blindness community, we're all part of the VI community. If you are, in touch with specific blindness organizations, I'm in conversation with some people as well, but if you think that, you have contact with someone in an organization that you've enjoyed these sessions and that you would like to see more of this kind of work happen, either in terms of creating resources or in terms of, teaching workshops, so on, then, feel free to reach out to them and say, hey, this was really good. We would like to see more of it. And then, and hopefully I would love to see the major blindness organizations put some more resources specifically behind these kinds of more modern skills that I think are important for the blindness community. Another thing that I'm in some conversation with some organizations is, maybe having like some small grants or small prizes for infrastructure development and so on. So that would, I really think that some of the big organizations should get behind some of this work. If you have contacts in those, just reach out to me, drop me a line, and put a word in someone's ear, and have them reach out to me. So and I also just want to thank all of you participants. I mean, you guys have really come out in large numbers, and there's a huge number of people who are following along asynchronously as well and reaching out by email every week and everything like that. So there's actually kind of a hidden group of blind folks who are really interested in learning data science that is even larger than we're seeing in these rooms, and they are pretty big crowds in these rooms too. So thank you. I just want to thank you all for coming out, for learning. I know it's challenging, but it's been great to connect and to see this, hopefully it's a start of something cool. So, all right, that's enough spieling. Sarah, do you want to, I'll introduce Sarah Kane. She is a PhD student in astronomy and astrophysics at Cambridge, and Marshall Fellow, and she's going to be leading our second workshop right now on sonification. So Sarah, it's enough talking from me.
Thanks, Patrick. All right. Hi, everyone. Excited to get started again. I'll share my screen. I have share my screen. Hello. All righty. Make sure share sound is on, and we are good to go. Before we begin, I just want to mention off my camera because someone had the suggestion that might help with some of the difficulties we had last week. So let's hope for the best. Apologies if anyone is low vision or sighted here, if you don't appreciate me being, just a square. Sorry, but we're going to give this a try. On the topic of audio difficulties, I know we had rather extensive audio difficulties last week. I just want to mention that there is a nice fresh recording. I re-recorded the tutorial from last week. So if you found last week a little difficult to follow because of some of the audio difficulties, I highly recommend you go check out the new recording, especially right at the end when we listen to all of those sonified shapes that we made. I think that's the most informative part of the tutorial, so I highly recommend going to check that out if you are interested. I'll also mention that we still seem to be having some audio difficulties where sounds from the terminal do not seem to like to play through Zoom that we can tell. So I'll just tell you in advance that all the sonifications for this week I have pre-prepared as audio files. So, when I'll have you guys typing sonification.play or whatever we name it to get things going, I will click away to an audio file and play the sonification for you from there. And hopefully we will be on our merry way. All right, now I'm really done spieling. Let's see. I'm gonna turn NVDA speech back on.
Speech mode beep, speech mode talk.
And I just want to confirm, can you hear that okay? Yes, no?
Yes.
I'll take some.
Yes, we can. Thank you.
Excellent.
Yes.
All right. Oh, and I don't hear that active speaker alert, so maybe the video off is the answer. Alrighty, so as we always do, I'm going to ask you to begin, please, by opening Anaconda prompt. You can do that by hitting the Windows key and then typing Anaconda prompt, and it should be the first result that comes up after that. And once you are in Anaconda prompt, we will start IPython by typing, as we always have, IPython, all lowercase, all one word.
I P Y T H O N. Python 3.11.5 packaged by Anaconda Incorporated.
All right, I think we've heard that a bunch of times. I wanted, us to hear the Python version one more time, but we probably don't need to listen to that whole thing. All right, so now we are in our interactive IPython environment, and we are ready to get started. The exciting news is today we are going to sonify some real data. What I have prepared for you is a CSV file of temperature data. This is real data, real temperatures from cities around the world, and also some rainfall data. We'll look at that data in detail before we sonify it, but in order to actually import that data, we are going to need to import our favorite packages that we've used all along. We're going to import NumPy and import pandas. Hopefully this is a familiar procedure by now. I'm going to start in that in one line by typing import NumPy.
IMPORT.
So that's import space NUMPY, NumPy.
NUMPY. Into.
All right, and it's telling me I'm on the next line already. We don't expect any output from importing something, and I'm going to type import pandas like the bear.
IMPORT space PANDAS. In 3.
All right, I've typed import pandas, hit enter. And this is the moment where I'm going to ask one of the helpers, I think Alex or Elizabeth has it at the ready, to copy and paste 2 lines of code in. This is going to be the URL that we're using, and then it's going to be df equals pandas.readcsv, that URL, and the index column equals 0. Basically, this is saving us that step of typing out the URL, so I highly recommend you go and copy and paste that from the chat, because it's rather a long URL link, and then it's just our very familiar pandas.readcsv. I myself am going to copy and paste it in as well, because it's a long URL.
IPython, C. Win, URL, I, desk, command prompt terminal IPython, C users /rob, COL equals 0.
All right, it just read the very last bit of what I just copy and pasted in. But the important thing is, again, to remember that we're doing this df equals pandas.read CSV, that URL. So what we're doing is we are making, as we always do, a pandas CSV from the data in that, or not a pandas CSV, a pandas data frame from the data that's saved at that URL, and we're calling it df. And I'm just going to hit enter. Might take a second.
In 4.
Did about a second exactly. You can hear it says in 4, we're on to our next line. Now, the data is all already there. Unlike last week, we're not going to sort of craft any of it ourselves, but I am very strongly of the opinion that we should not be sonifying or visualizing, representing our data in any way until we actually take a look at that data. And all you really know about this data is that it's something to do with the weather. Like I've mentioned something about temperature. You don't really know what's in here. So I don't know about you, but my very first question is, what is actually in this data? What are the columns? And so you might recall from Patrick's lessons that we can check on the columns in the data frame by doing df. That's what we've named that data frame in those lines I had you copy and paste. So we'll do df.
df.
And then dot.
Dot Philadelphia temp dot me.
Whoops, it wants to suggest something I've typed before. I don't want to do that. I want to do df dot columns.
COLUMNS.
That's df.columns and hit enter. I'm going to tell you now that this is going to be a rather long output because there are 13 columns in this. So we're gonna listen to them all the way through because again, we want to know all the columns in our data frame if we're using the thing.
Out 4. Index, year, month, day, New York City temp, Philadelphia temp, Pittsburgh temp, Orlando temp, Austin temp, Seattle temp, Delhi temp, Delhi rain inches, Delhi temp model 1, Delhi temp model 2, type equals object, in 5.
All right, so what columns do we have here? We have 3 columns that specify the date, that is the year, month, and day at which we have our data. Then we have a whole slew of columns with the temperature, presumably daily temperature, in a bunch of different cities, New York City, Philadelphia, Pittsburgh, Delhi, India, blah, 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 blah. We're not going to use all of those columns, but I wanted to A, give you a larger data frame to handle because this is often how data comes, and B, because if you want to play around with more data, then it's available for you after this tutorial. You already have something you can sort of test and mess around with. So plenty of data available for you. If you're interested in where I got this data from, it's all linked on the curriculum online. So if you're curious, feel free to check it out. It is from 2 different sources that I curated and put together. There was a little bit of like processing that I did to sort of get it in a format that would be roughly convenient for us to use. We have that Delhi rain inches column. That's the daily rain in Delhi, India in inches, as the name says. And then those last 2 columns, the Delhi temp model 1 and temp model 2, those are actually columns I created. And we'll get into those a little bit later if we have the time. But essentially, they are predictions for the temperatures in Delhi, India. And one of them is intended to be a good prediction, and one of them is intentionally quite a bad prediction. But we will get into that later. All right, so now we know roughly what is in this data frame. My next question is like, how big is it? I've told you there are 13 columns, but I just want to print out the whole shape. You know, I mean, if I weren't here to tell you that I know there are 13 columns, I don't know about you, but I wouldn't want to sit and like count the columns. And I also want to know how many rows there are, how many days of data are there. So I'm going to do, as Patrick taught us, df.shape.
df.shape.
df.shape, and I'll hit enter.
Out 5, 9,265, 13, in 6.
All right, so there are 9,265 rows of data. That is, each of those I'll tell you is 1 day of data and 13 columns. I can tell you right now that because I've handled this data already, that's about 15 years worth of weather data in this CSV. So it's rather a lot, but my next question, after knowing, well, this is a rather large file, is, all right, but like what dates does it actually run from? And the way I can find out is by indexing the first and last columns. I'm going to assume this data runs in chronological order. First, because shuffling up the dates would be chaos, and I have yet to see a data file that does that. But B, because I have already, handled this data. So I'll tell you it runs in chronological order. So if we check the first day or the first row of data, that should be the first day of data, so we can get the first date. And if we check the last row of our data frame, that'll be the last date of data, so we can know when our data starts and ends. And again, Patrick taught us how to get how to index by row number. That's going to be df dot il
dot il
oc. So iloc, like loc for location, and then I like index, because we're indexing by number. Then it's going to be open square bracket,
left bracket,
0,
right bracket,
not parentheses, brackets. Why is it a 0? Well, Python likes to number starting from 0. So if we do df.iloc brackets 1, we're actually going to get the second row. All right, let's hit enter.
Out 6. Year 1995.000000, month 1.000000, day 1.000000.
Keep reading all of the column values in that row. I actually only care about those first 3, the year, day, or the year, month, and day, because that's the date that I care about. Annoyingly, they're in decimal format, just because that's how this file has read in. It's read in as floats, you'll recall we call them. But I can tell that the year is 1999, the month is 1, and the day is 1. So our data starts on January 1st, 1999. All right, when does our data end? So what is the range of dates for our data? Well, then I'm going to do df.iloc.
df.iloc.
Open brackets, so the same thing as the line before so far.
Left bracket.
Now, I could do what? What was the length of the data frame? 9265. I could type because I know how many rows there are for the last one, but that requires me remembering how many rows there are in our data frame. So a nice little shortcut is that if you want to index the last row of the data frame, you can just type -1.
-1.
-1. So it's df.iloc, open bracket, -1, close bracket.
Right bracket.
And the fun thing is, if you do, for instance, -2, that'll give you the second to last row, -3, third to last row, so on and so forth. This is another sort of Pythonic numbering thing. Maybe other programming languages do it as well. I don't know. Don't quote me on that. I only know Python.
Out 7. Year 2020.000000, month 5.000000, day 13.000000.
All right, and I'll stop it again after the day because I'm not interested in hearing how hot it was in Austin, Texas on, as we now know, May 13th, I believe it was, of 2020. So we have just about 15 years of data in here. So that's great. Now we know how large our data frame is. We know the time range. We know roughly what sort of data is in it. Cool. We're getting a good picture of things in this data frame. And then the last thing I'm going to want to do before I sonify things is actually take a look at one of the columns. I'm going to do Philadelphia because that's where I went to undergrad and I love Philadelphia. And I know roughly what the weather should be like in there, like in the city of Philadelphia. And I just want to check on the data in the Philadelphia column first to make sure nothing seems funky. Second, I don't even know right now whether this is in degrees Celsius or degrees Fahrenheit, which is, a little problematic because there are no labels here, like no units. But if I take a look at the data, I can probably guess based on the numbers we get out whether it's in degrees Celsius or Fahrenheit. And I would like to know that. All right, so the way I can do this is, if you recall from the list of column names, and no worries if you don't, because I'll tell you, the temperature in Philadelphia, that column name is called Philadelphia_temp. And so following the syntax that Patrick taught us, if we want to say check the average temperature in Philadelphia, then I can do df dot Philadelphia.
Dot
That's going to be
H
I
L
L
A
A D
D
E L
E L
P
P H
I
I A.
You know, before I did university in Philadelphia, I actually had a really hard time spelling that city. All right, so that's df.Philadelphia underscore
Line
temp, T-E-M-P.
T-E-M-P.
So this is just calling the Philadelphia temp column from df, and then I just want the mean attribute. So dot mean, M-E-A-N.
Dot M-E-A-N.
And then open parentheses, close parentheses, just like Patrick taught us.
Left paren, right paren.
All right, and let's hit enter.
Out 8, 56.417004856988867, in 9.
All right, so the average temperature in that Philadelphia temperature column is about 56 degrees. That tells me for two things. First of all, having spent time in Philadelphia, sounds about right to me. It sounds about right if it's in degrees Fahrenheit, because if that's in degrees Celsius, Philadelphia is on fire, which I certainly hope it isn't, because I would like to go back to visit. So I know two things. First of all, from a rough analysis, that average seems correct. And also, I now know our units are in degrees Fahrenheit. I can also, and for the sake of thoroughness, I could also check the max. That's going to be the same line we just typed, except instead of dot mean, it'll be dot max. So we can do df dot Philadelphia
dot P-A-I-L-A-D-E-L-P-H-I-A line
Philadelphia underscore temp
T-E-M-P
dot max
dot M-A-F left paren, right paren, out 9, 92.9, in
Right.
10.
All right, so the maximum temperature we have recorded for Philadelphia is 92.9 degrees Fahrenheit. I'll tell you for certain that it definitely gets hotter than that in Philadelphia, so I would be scratching my head a little bit about this and feeling some concern, except for the fact that I believe that this is actually the average temperature over the whole day. So if you consider the fact that it's like cooler in the night, yeah, I can imagine that the hottest day in Philadelphia is on average 92.9 degrees. For the sake of completeness, let's look at the minimum.
D F dot P H I L A D E L P H I A line T E M P dot M I N left paren, right paren.
So that is df dot Philadelphia underscore temp dot min, open parenthesis, right, close parenthesis. That is the same line we have been typing, except now instead of mean or max, it is min. And let's just see what we get.
Out 10, 9.4, in 11.
9.4 degrees Fahrenheit. Yeah, that sounds right to me. For your Europeans, that's going to be, I don't know degrees Celsius. I'm going to bet on like -10 Celsius, something like that. Miserable. Miserable is the temperature. All right. We've explored our data frame. We know what's in it. We know like the columns, we know the date ranges, we know actually the type of data we have in here. We've checked the column we're going to sonify first, Philadelphia, and made sure that everything seems to be in order there. I think we're good to go. Let's get into actually sonifying. Now, inherently before we visualize something, visualize or sonify, so before we represent data, there's always going to be some legwork we have to do. The legwork we're going to have to do here is 2 steps. First, what we're going to want to sonify is the Philadelphia temperature versus time, or versus our date. However, right now, our date is spread across 3 columns. It is year, month, day. That is going to be really difficult. Actually, that's going to be impossible for Astronify to parse. Like those 3 columns, that's not going to work. We don't want that. Why did I leave it this way? Well, first of all, this is a format you'll often see in data. It's the way the data originally came, so I want us to be able to work around it. What are we going to do is we're going to make a new column in our data frame. I'm going to call this time step, and this is going to basically be the number of days since our data began. So the first day, January 1st of 1995, will be 0. January 2nd will be 1, January 3rd will be 2, and so on and so forth. This will now act in our sonification as the time column, because those nice just numbers will be easy for Astronify to parse. And in the sonification, Astronify doesn't really care about the value of the time, it cares about the distance between times. So what I'll call the time step. That's why I'm calling this column the time step column. It's because say we took, the data every day and then suddenly we took it, a week later, so there's a larger gap, that could be a problem. But here the data is taken at really regular intervals, just once a day for about 15 years. So we can make sort of a fake time column, and Astronify will treat it just the same, and it'll work out very well for us. So Patrick already taught us how to make a column like this. And I will refresh your memory if you don't recall. First, we're going to call the column, though we haven't made it yet. That's going to be df.
df.
Open bracket.
Left bracket. Time step equal.
It's trying to complete things for me. I'm not there yet. Give me time. All right. Df, open bracket, quotation mark or like little tick mark.
Tick.
Then it's time step, all one word. So time step, TIMESTEP.
TIMESTEP.
Time step, close quotation mark.
Tick.
Close bracket.
Right bracket.
So this is a slightly different syntax from the one you were using with Patrick. To call a column, here we're using brackets and quotation marks instead of the dot format, which is, I think, maybe a little quicker to type. This format, in my experience, just works better for creating a new column. So we are making a new column of the data frame. There isn't already a column called time step. We're creating a new one. I found when you do df dot time step, to make a new column, it throws an error. So this one time we'll use this different syntax here to call the column. So that's df, open square bracket, open quotation mark, time step, close quotation mark, close square bracket, space, equals, space. And then the function we're going to use here is the one that Patrick taught us, pandas.rangeIndex.
PANDAS dot.
So that's pandas dot, the R in range is capital.
R.
So that was a capital R, ANGE.
ANGE.
Then index, capital I. So capital R in range, capital I in index.
NDEX.
And it's all one words. So pandas dot range index, open parenthesis.
Left paren.
Then it's going to be start equals 0.
START equals 0.
So we've opened quotation marks, no, not open quotation marks, open parentheses, start equals 0. That means the start of our steps will be 0. So remember, that's going to mean that January 1st of 1995 is time step 0, comma, then space, then I'm going to do stop,
STOP equals,
stop equals, I'm going to type LEN, then I'm going to do open parenthesis,
left paren,
DF, close parenthesis,
right paren.
That means stop at the length of our data frame. In this case, that'll be, I think, what was it? 9,625, 9,265. Clearly, I can't remember off the top of my head exactly the number of rows in our data frame. So the LEN, open parenthesis, close parenthesis, with df in the middle will just automatically give us the number of rows in data frame. And that's because I want that last date, which was what, May 13th of 2020, 2020, what a year. May 13th of 2020, I want that to be, 9265 or whatever the last row index is in our time step column. So that's going to be stop equals len, LEN, open parenthesis, DF, close parenthesis, comma, and then I'm going to type space, step equals 1.
STEP equals 1.
Step equals 1, so just increase in steps of 1. So January 2nd should be day 1, January 3rd, day 2, so on and so forth. Again, counting from 0 as Python likes.
Right paren. In 12.
All right, hit enter. All set. If we want, we can check on that new time step column. So maybe I'm going to do df.timestep.
df. Dot. Dot Philadelphia temp. Dot.
Again, it's trying to guess what I want. It's wrong. df.timestep, and I'm going back to this more familiar syntax of df dot to call the column.
timestep.
And then I'm going to do dot head, and that'll return the first 5 rows of this time step column, just to check that everything seems okay.
Dot head. Left paren, right paren.
So that's df.timestep.head, open parenthesis, close parenthesis, hit enter.
Out 12, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, name, time step, type, in 64, in 13.
All right, so you might have heard 0, 0, 1, 1. That's basically saying the 0th row is 0, the first, sorry, woo, long day. The first row is 1, the second row is 2, etc., etc. That all sounds good. That's exactly what we wanted. All right, I said there was 2 steps we needed to get this sonification going. And the second one is, you might remember that Astronify, the sonification package we use, wants its data in an AstroPy table. I'm not going to dig into that again. If you don't remember that, I recommend you go check the curriculum or the recording from last week. I explained about AstroPy tables. For now, we're just going to import table from AstroPy and then turn our data frame into a table. All right, so that's going to be to import the necessary class. That's going to be from
FROM.
From astropy.table. So that's from space AST ROP Y dot table space import space, and then this is going to be table again, but with a capital T. So that's capital T table. From astropy.table import table.
In 14.
All right, that went through no problem. Hopefully it did for you as well. And then this is the exact same thing we ran last week. I'm going to use the AstroPy table built-in function from underscore pandas that will take a data frame, our data frame df, and return a table, which I'm going to call TBL. So that's going to be TBL space equals space. And again, these spaces just make it nicer if you're gonna pass this like this IPython session onto someone sighted who's reading it, or I'm low vision, so I'm reading this now, and I find it easier if things are separated. So I'm doing it for my own sake as well. But if you don't want to include the spaces, you don't have to. So that's TBL equals space capital T table. Sorry, I accidentally typed in a capital, ooh, I'm struggling today. A capital A, I don't want a capital A, just capital T table. Dot from underscore pandas.
Dot FROM line PANDAS.
Open parenthesis.
Left paren DF.
Close parenthesis.
Right paren.
So that's TBL equals capital T table dot from underscore pandas, open parenthesis, DF, close parenthesis, make an AstroPy table from the pandas data frame called DF, that's our data frame, and call it TBL.
In 15.
Hit enter. And if we just want to double check on that table like we did last week, we can type tbl.callnames.
TBL.
That is COL names, not call like a phone call. COL like the beginning of columns. So
dot call names.
There it goes. Trying to again, except this time it's right. TBL.COL.
COL.
NAMES.
NMES.
COL names. And you'll notice this is slightly different from how we get columns in pandas. Astropy tables are like similar, but not the same, just different enough from from pandas data frames to make you have to Google every time when you want to do something. But this will give us the columns in table TBL, just so we can check that they're the same as the ones in the pandas data frame.
Out 15, year, month, day, New York City temp, Philadelphia temp, Pittsburgh temp, Orlando temp, Austin temp, Seattle temp, Delhi temp, Delhi rain inches, Delhi temp model 1, Delhi temp model 2, time step, in 16.
All right, amazing. We have all the same columns, including that new time step column we made. Fancy, fancy. All right, I am about to sonify this, but before I do, if there are any persistent questions before we get sonifying, please do let me know. Now is a good time for that. I am hearing silence. I am hoping that is because there are no questions and not because my audio has gone out. But I am monitoring.
We can hear you.
Ah, excellent. All right. That's the better option. Sometimes I feel like because I'm sitting alone in a little room, I feel like I'm speaking into the void, you know? All righty. If I don't hear any questions, I'm going to keep on moving on, but feel free to ask questions in the chat. As always, we're going to get into the sonification. You might notice it took us quite a few minutes to get to this point. That is deliberate. Data representations are only useful if you know what's going on in your data. So it shouldn't be, I think I see people do this a lot. Heck, I'm in the habit of doing it too. You just sort of throw either a visualization or a sonification at your data. And that can be useful, but I also think it's useful to have a sense of what's going on first. So now we know what's going on in this data. That'll make the sonification a lot more useful. All right, let's get into it. We're going to import Sona series from Astronify, just like we did last week. So that's going to be from
F-R-O-M.
From Astronify. So from space A-S-T
A-S-T
R-O
R-O
N-I
N-I
F-Y
Y
Astronify dot series
dot S-E-R-I-E-S
from Astronify dot series space import
I-M-P-O-R-T
space Sona series. That's capital S in Sony, capital S in series. So that's capital S O-N-I
O-N-I
capital S
S
and then the rest of series.
E-R-I-E-S
From Astronify.series, import Sona series.
WX Python is not found for the current Python version. Pio will use a minimal GUI toolkit written with T.
All right, I'm not going to play that the whole way through. I think basically everyone I've spoken to has gotten this sort of warning. I wanted to play a little bit of it again, just so you know not to worry. I think there's this like audio Python package called Pio that Astronify is built on that is going through some changes.
Show small active speaker video.
Oh no,
Selected
don't
alert.
Be back.
Show small
Oh my gosh, we had all this time of silence and then I get that speaker alert again?
Desk, hide thumbnail, hide desktop.
All right, we're gonna hope that that doesn't come back for good. I enjoyed that not happening like it did last week. So everyone please cross your fingers for me. Okie dokie. Okay. So don't worry about that. I will say also, from, some testing I've done from preparing for this tutorial, I don't necessarily know whether it's Astronify or Pio, which Astronify is built on. It has some technical difficulties, so you might encounter those now. So one of the most common problems I've noticed is a persistent clicking noise during the sonifications when you play them from the terminal. I have saved the audio as a file, which is how I'll play it for you, because it's from the terminal doesn't seem to play very nicely over Zoom. That does not have that persistent clicking noise. I don't know why it's in the terminal. I assume it's some sort of bug. I'll also say that sometimes there will be a persistent clicking noise for a couple of seconds before the sonification actually begins. Don't panic. And then occasionally, especially if you like didn't have headphones plugged into your computer when you started the terminal session, and then you go and plug the headphones in, when you try to actually play a sonification, it'll throw a little bit of a fit because it can't find the right audio output anymore. None of these are insurmountable issues. The like worst case scenario for any of these bugs is, well, a clicking noise, which is a little bit of a nuisance, or like hopefully none of you have to do this because this would make it very difficult. You'd lose your place, but like restarting the terminal session. I don't want you to have to do that right now, but if you encounter these bugs in your own time, don't panic. It's not like an insurmountable problem. It's just a little bit of bugginess just because this is a little bit of a smaller package. So just want to give you a heads up. Hopefully the helpers can help you in the chat. If any of these problems come up, you might see them crop up in my own terminal. But as I said, we have the sonifications all already saved. So one way or another, you will hear them. On that note, let's get sonifying. So I'm going to make an instance of the Sona series class. That's going to be our sonification object. And because I am sonifying Philadelphia temperatures, I'm going to call this Soni, S-O-N-I, underscore Philadelphia.
S-O-N-I. Line.
Philadelphia.
P-H-I-L-A-D-E-L-P-H-I-A.
Soni underscore Philadelphia equals.
Space equals.
And then I'm going to do space.
Space.
Sona series, again, remembering that the S's in Soni and series are capitalized.
S-O-N-I-S-E-R-I-E-S.
So that's Sona series, capital S-O-N-I, capital S-E-R-I-E-S, open parenthesis.
Left paren.
TBL.
TBL.
So make a Sona series object from the data in our table, TBL, comma,
space.
Remember again that we need to tell the Sona series class what our time and value columns are called. In our case, we've just made the time column. That's going to be our time step column. And then our value column is like the thing that's going to change over time is going to be Philadelphia temp. So let's tell Sona series that now. So we're going to do time underscore COL.
T-I-M-E line C-O-L.
TIME underscore COL time call equals open quotation mark
tick
time step, all one word because that's what we called that column.
TIMESTEP
Close quotation marks.
Tick.
Then add a comma. Space. Val underscore call VAL.
VAL line COL.
That's for value column. Space equals. Or I guess not space. We can do space here.
Space equal space.
That's probably the proper form. And then that column is called Philadelphia. Don't forget your quotation marks.
Tick.
Philadelphia.
P-H-I-L-A-D-E-L-P-H-I-A.
Underscore temp.
Line T-E-M-P.
For temperature, close your quotation marks.
Tick.
Close your parenthesis.
Right paren.
And hit enter. Oh my goodness, I'm getting a Zoom audio alert now.
Settings window. Security. Closes the window. Desktop Windows ML.
Can you hear me?
Yes, we can.
Indeed.
On.
Oh my goodness. Wow, we really can't win with the audio issues here. All right, we will plow forward. I got an audio alert saying that my audio device wasn't detected anymore. I didn't even try to play anything yet. All right, this is a rather long line of code, so maybe if one of the helpers wants to paste that into the chat. This is a good line of code to become familiar with, though, because we're going to use it over and over, basically just changing the name of the sonification, so we won't sonify Philadelphia all the time, and then also changing the name of the value column from Philadelphia temp to some other column that we might be interested in. All right, next I'm going to sonify this thing.
S-O-N-I, line, P-A-I-L-A-D-E-F-P-A-I-A.
So what I've done here is I've typed Sony_Philadelphia again. That's SONI_Philadelphia to call that object again. Then I'm going to hit dot.
Dot
And
right.
It wants to do something else. I don't want it to do that. And I'm going to do dot sonify. That's S-O-N.
S-O-N.
I-F-Y.
I-F-Y.
I'm going to do open parenthesis, close parenthesis.
Left paren, right paren.
And then that's it. I'm going to hit enter. So it's Sony_Philadelphia.sonify. So make the sonification out of the Sony Philadelphia Sona series, instance. So make the sonification. This isn't going to play the sound quite yet.
In 19.
So I just hit enter. It's now sort of done all of its pitch mapping. It's ready to go. It's, found how it's going to represent the sounds. The last step is to play the thing. I am not even going to, well, I'll try once to play it from terminal. I don't have the highest hopes, but we'll cross our fingers. We have the audio file ready. And I want you to keep in mind from last week that remember, Astronify maps pitch to the value such that by default, higher values are mapped to higher pitches. So what you should hear here is higher temperatures represented as higher pitches and lower temperatures represented as lower pitches. I think the sonification is pretty fun. My office mates tell me that they think it sounds like wind, which is not a bad thing. And the way we are going to play the sonification, you might recall from last week, is Sony, S-O-N-I.
S-O-N-I.
_ Philadelphia.
Line, P-H-I-L-A-D-E-L-P-A-I-A.
Dot play.
Dot, P-L-Y.
Open parenthesis, close parenthesis.
Left paren, right paren.
Sony_Philadelphia dot play. If anyone wants to take bets over whether this is going to actually work on Zoom, please feel free. Now's your chance. Hopefully it will work on your computer. It works on my computer when I'm not on Zoom. There just seems to be an ongoing disagreement going between Zoom and whatever terminal audio situation is going here. So I don't have the highest hopes.
But close desktop iPad dot right in 21.
All right, I don't believe that worked. Hopefully you can hear me again, but I
It
don't
did.
believe you heard. Oh, it did?
It
Oh my
worked.
gosh,
It
did I
did work.
stop it when it was working?
It worked. Can you redo it without your screen reader on?
Yeah, oh my goodness. I am absolutely astonished. All right, I'm going to turn off NVDA. I'm going to type that Sony Philadelphia again, dot play again. I stopped it early, so we didn't hear the whole thing. And we'll cross our fingers that it works a second time. Wow, I would have just lost that bet.
Speech mode off.
Do you know about the up button?
You mean to the up button?
Yeah, if you don't have to retype this stuff, if you've already typed something.
Yeah, I could, but I want to, I don't want to
Gotcha.
take.
Sorry to interrupt you. Got you.
But yeah, okay, here we go. Let's cross our fingers again. Okie dokie. I'm hoping that went through. And you might notice that's a rather long sonification. That's because we have a lot of data points there. So it takes a long time. Last week, actually, you might remember me changing the note spacing by doing like the dot note spacing. There I was slowing it down because we had relatively few data points. There we had like 100. Here we have over 9,000, I believe. We don't want to slow this down anymore. This is already, I think, over a minute of sonified data. So we definitely don't want to slow it down. You can play around with the note spacing and speed it up if you want. I didn't think it worked very well sped up. I think it was a little hard to interpret, but feel free to putter around with that if you would like. The default note spacing is I think 0.01 seconds between each note. So feel free to go wild and change that just like we did last week if you want to. There are a couple of things I want you to think about. First, notice how you could hear those up and down cycles of the temperature going up and down and up and down at sort of regular intervals. You are literally hearing the turn of the seasons. You're hearing years go by in the data as those moments of higher pitches are the miserably swampy Philadelphia summers, and the moments of lower pitches are the miserably cold Philadelphia winters. I do actually really love Philadelphia, don't get me wrong. But so you're hearing the cycle of the seasons in the sonification. That is one of the fastest non-visual overviews of the data to get that sort of sense of the shape that we can do. Because think about it, if you didn't know Philadelphia was, sort of a temperate place, say you don't know whether it's like the desert or like Antarctica where there's maybe not as much of a cycle of a season, all you have to do is play that and immediately, Philadelphia has seasons. Another thing that you might want to notice from the data, something that might be adding to sort of that wind-like effect that we have going there, so that's a little, what I'm going to call wobbly. It is not like a perfect wave-like pattern where it goes up and down perfectly, like that sine wave that we made last tutorial. That's because this is real data, so you could get like an anomalously hot day in the winter and a nice cool day in the summer, or at least you could dream of a nice cool day in the Philadelphia summer. So the data is not following a perfect trend, and I think that sort of contributes to, that spooky wind vibe. All right. So that's our first sonification of the day, and your first sonification with real data. We are, and also I'm not going to play it again now because it's rather long, but I totally encourage you if you want to like play it again later. You can listen, maybe see if you can count all 15 years of our data in there, things like that. But I think one of the best ways to learn more about this sonification is going to be to sonify something else and compare it. So let's dive right into our next sonification. We are going to sonify the daily temperature in Delhi, India. So let's make a new instance of the Sauna series class. So that'll be, actually, before I break into that, I just want to see, do I have any questions? Because we've finally burst into the sonification scene. So if there are questions, I'll address those now.
When you just played that sound and it repeated, does it repeat indefinitely, or do you have control over that?
Yeah, that's an excellent question. So it sounded like it was repeating, but actually those were just multiple years of data we have. So it won't repeat indefinitely. It'll repeat for those 15 years of data we have. So there were 15 cycles there. Now I know this is rather a long sonification. So if I didn't want to listen to it till the end, which we did this time, we listened to it till it stopped. So that stopped on its own. That wasn't going to go on forever. If I want to stop it early, I can type Sony_Philadelphia.stop, open parenthesis, close parenthesis, in the same way we did .play. So stop and play are sort of parallel to each other. I might do that later. I should probably even add that to the curriculum because I don't think I wrote it down there. But yes, it is not indefinite. It goes, basically the time is determined by how many data points you have, and then the duration of each note, and then the spacing between each note, we're using the default duration and spacing, so how of the notes that Astronify gives us, but again, you can play around with those. Those will affect how long the sonification is. So yes, this is a rather long one, but it's not indefinite. All right, I hear some silence, so I'm going to turn NVDA's speech back on.
Speech mode beeps, speech mode talk.
Excellent, we are back in business, and I'm going to make that sonification of the Delhi, India temperature. So I'm going to do Soni underscore Delhi.
S.
Oh.
S-O-N-I.
And Delhi has, I guess I'm probably butchering the pronunciation, but it's like Delhi, so an H after the L. So Soni, S-O-N-I underscore.
Line, D-E-L-H-O-O-I dot play.
That O was a typo, so that's SONI underscore DELHI.
I.
Space equals.
Space, equals, space.
And we're going to make this again an instance of our Sona series class. So that's capital S.
S.
O-N-I.
O-N-I.
Series, capital S again.
S. E-R-I-E-S.
So Soni underscore Delhi equals Soni series with capital S's. Open parenthesis.
Left paren.
TBL.
T-B-L.
Comma.
Comma.
So again, make a Sona series object from the table TBL, space.
Space.
Time underscore call, so call COL like column.
T-I-M-E.
Underscore call like column.
Line. C-O-L.
So time underscore call equals time step in quotation marks, just like last time. So our time column is again that column that we made that we called time step.
Equals tick. T-I-M-E-S-T-E-P.
Quotation mark.
Tick.
Or tick. Comma.
Comma.
Space.
Space.
Val call for the value column, VAL.
V-A-L.
Underscore call, COL.
Line. C-O-L.
Equals. Open quotation.
Tick.
And then the Delhi temperature column is called Delhi underscore temp.
D-E-L-H-I.
Underscore temp.
Line. T-E-M-P.
And then close your quotation marks.
Tick.
Close your parenthesis.
Right paren.
So to summarize, that is Soni with an I, S-O-N-I underscore Delhi equals Sona series with those capital S's, open parenthesis, TBL, comma, time underscore COL equals quotation marks time step, close quotation marks, comma, val underscore call equals open quotation marks, Delhi underscore temp, close quotation marks, close parenthesis. So make a Sona series, a sonification object, call it Soni Delhi, from the table TBL, call the time column time step, and the value column is the daily temperature in Delhi, India. Hit enter.
In 23.
Good to go. And then these next two lines should hopefully be familiar. It's going to be Soni underscore Delhi.
S-O-N-I.
Underscore Delhi.
Line. D-E-L-H-I.
Dot sonify.
Dot. S-O-N-I-G-Y.
Ooh, not G.
Y-G-F-Y.
Sonify, not sonic guy. That's not it.
Left, right paren.
And don't forget those parentheses at the end. So again, this is just going to actually sonify our data. So map things to pitch, map the values to the pitches the way we want.
In 24.
And then Soni underscore Delhi dot play.
S-O-N-I. Line. D-E-L-H-I. Dot. P-L-A-Y.
And again, don't forget those parentheses, open and close.
Left, right paren.
Because this is, a function we're calling, but we're not entering any parameters. So we just leave some empty parentheses there. And we will, again, cross our fingers that this works. And we'll hit go. And again, this is going to be a rather long one. So.
PIO warning. Port speech mode off.
Pretty cool, huh? So I noticed a couple of things about that Delhi temperature sonification. First, I noticed that there was like less noisiness. It seemed, what I mean by that, like there was less wavering, so it seemed more of a smooth trend. So maybe Delhi is less likely to have that random like hot winter day that Philadelphia could have. It also sounded to me like there is more variation between, the hottest and coldest days. But one of the things I noticed is that, like, on average, the pitch, like the average pitch of that sonification was pretty similar to the average pitch of the Philadelphia sonification. And I've never been to India, but I kind of expected Delhi, India to be a lot hotter on average than Philadelphia. And thus I would expect, naively, the average pitch of our sonification, knowing that higher temperatures are represented by higher pitches, I would expect the pitch of our sonification to be higher on average. I'm going to check that because, I don't know for certain whether maybe Delhi's actually really cold. So we've already done this for Philadelphia, and this is one of the reasons why I recommended you do this before you sonify something. Now I have to go back and check the average temperature in Delhi, India. I'm going to check this using the data frame. So our data frame DF still exists in this IPython session, even though we've been using TBL or table since. That from pandas function, not going to destroy our nice data frame, fortunately. And as I mentioned before, the syntax, like the way we access AstroPy tables is like just different enough from pandas data frames to be inconvenient. And frankly, unless you intend to be an astronomer, you don't need to learn how to deal with AstroPy tables. I think sometimes even astronomers don't know how to deal with AstroPy tables. So let's work, and the data in our data frame is the same as the one in our AstroPy table. So let's work with the data frame. So I want to test the average temperature in Delhi, India. So that's going to be DF. Oh, I got to turn my speech back on.
Speech mode beep, speech mode talk.
Got to remember to do that. Okay, so that's DF.
DF.
Dot Delhi _ temp.
Dot DELHI line TEMP.
Dot.
Dot
Mean for average.
MEAN. Left paren, right paren.
That's DF dot Delhi _ temp dot mean, open and close parenthesis.
Out 25. 76.965213167835994 in 26.
All right, so that's like what, almost 77 degrees Fahrenheit on average. And I recall that the average temperature in Philadelphia was like 56 degrees Fahrenheit. So this is about 20 degrees hotter on average than Philadelphia. So it's sure, like on average, a lot hotter. Let's hear maybe like what the minimum temperature in that Delhi, India column, temperature column is. So that's going to be DF dot Delhi _ temp dot min, open and close parentheses.
FG.
Whoops, that's not correct.
GF. DF.
Dot Delhi _ temp.
Dot DEA line.
Oh, hey, Alana, you good over there? Okay, sorry, checking on the guide dog. Heard a suspicious noise, didn't like it.
TEMP.
DF dot Delhi _ temp dot min.
Dot MIN.
Open and close parenthesis.
Left paren, right paren, out 26, 43.9, in 27.
All right, so the coldest temperature we have recorded for Delhi is 43.9 degrees Fahrenheit. And I think it was what, like 12-ish for Philadelphia? So it is never getting as cold in Delhi as it gets in, well, I mean, some days it'll, but like it never gets as cold as the coldest temperature in Philadelphia. And that is not immediately obvious from the sonification. What gives? Well, what is happening is we are creating individual sona series objects for each of our sonifications. And in order to make a sonification that sounds nice, Astronify maps and scales each of these sonifications individually. What do I mean by this? Well, they map the values of our temperatures to pitches independently of each other. So a note that we hear in the Delhi sonification is not even if it's the same like pitch, it's not representing the same temperature that we hear in the Philadelphia sonification, because the pitch mapping is different, because the scaling is different by default. So again, these are the default settings, and they do this to make it sound nice. And in fact, this is not a unique thing to Astronify or to Sonifications. The most common Python visualization package, matplotlib, is going to automatically scale our visualization axes based on the data points you give it as well. So this is not a sonification unique thing, but because these are the default settings, we do, oh goodness, are you good? Sorry, guide dog, having a moment. Okay, because these are the default settings, we can fiddle around with them. And the one setting we're going to want to change, the pitch mapping parameter we'll want to change in particular in Astronify, is something that they call the 0 point. Basically, they pick some central pitch of the of the data. By default, they will pick the median value of our data and map that to a central pitch of 440 hertz. I can't like conceptualize in my mind exactly what 440 hertz sounds like, but that's like sort of I take it the center of the pitch range of the sonification. And so every time what Astronify does is it calculates the median of the data and says, all right, we're going to represent anything like this median value as 440 hertz in the sonification. But because Delhi and Philadelphia are such different temperatures, they have very different median temperatures that are being represented by that same pitch. Fortunately, we can change, again, what Astronify calls the 0 point, so we can change the value that it's mapping to that central pitch. So what I'm going to do is I'm going to change the central, or not the central pitch, the 0 point. Sorry, I'm going to change the 0 point of the Delhi sonification to be equal to the median value of the Philadelphia temperatures, because we know that the Philadelphia sonification is going to be scaled to its median by default. So I'll just set the Delhi sonification to be scaled to that number too. I could scale them both to some arbitrary number. I could set their 0 point for both of them to be like, I don't know, 70 degrees. But at this point, this way we only have to change one of the sonifications. We can just muddle around with one of them. So the first thing I need to know is, hey, what's the median value of the Philadelphia daily temperature? We've printed out the mean, the average, but I want to know the median because that's what Astronify by default is using. So to do that, I'm going to do df.
F.
No.
F.
Sorry, lots of typos today. df.
D. F.
Dot Philadelphia underscore temp.
Dot P A I L A D E L P A I A line T E M P.
Philadelphia underscore temp dot median MEDIAN.
Dot M E D I A N.
And don't forget those parentheses.
Left paren, right paren, out 27, 57.0, in 28.
All right, so the median temperature in that Philadelphia temperature column is 57 degrees. Now, this line of code that I'm going to use is basically letting me go into what Astronify calls the pitch map arguments. So the sort of parameters it uses to map the values of our data to pitches in the sonification. I'm going to dig into those, and I'm going to change the 0 point pitch map argument to be 57 of the Delhi sonification, because that'll make it the same as the Philadelphia 0 point, because by default, again, the Philadelphia 0 point will be 57, its median value. This is a rather long line of code. I'll go through it here. Maybe one of the helpers can sort of fling it into the chat as well, just because it's kind of got like a lot of dots and blah, 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 so on and so forth. All right, let's do Sony underscore Delhi.
S-O-N-I line D-E-L-H-I.
So I'm calling that object again, that's Sony underscore Delhi object.
Dot.
And then I want to go pitch underscore mapper.
P-I-T-C-H line M-A-P-P-E R.
So Sony underscore deli dot pitch, pitch underscore mapper, mapper. So call the pitch mapper, call the way that the deli temperature data is being mapped to pitches. And then we want to call the pitch map args, the pitch map arguments. So sort of the parameters of the way these pitches are being mapped. So
Dot.
pitch
P. I. T. C. H.
underscore map
Line. M. A. P.
underscore args, ARGS.
Line. A. R. G. S.
So just to summarize so far, that's Sony underscore deli dot pitch underscore mapper dot pitch underscore map underscore args, ARGS. Open square bracket,
Left bracket.
open quotation marks,
Tick.
then 0 underscore point
Z. E. R. O.
underscore point,
Line. P. O. I. N. T.
close quotation marks,
Tick.
close brackets.
Right bracket.
So basically, what have I done here? I've called the pitch map argument 0 point. So that thing we've been discussing, that point in the data that will be represented every time as 440 Hertz. I'm calling that from this deli sonification. And I'm going to set it equal to
Space equals
57.
space 5 7.
Because that is the median value of our Philadelphia temperatures. And I'm just going to hit enter.
In 29.
All right. That bit is done. The only two things we have left to do, we have to, in order for it to play properly, we have to re-sonify the data. So basically we have to remap the pitches, the values of our data to the pitches.
O. N. I. Line.
So that's Sony underscore deli
D. E. L. A. I.
dot sonify, as we're familiar with.
Dot. S. O. N. I. F. Y. Left, right paren, in 30.
And before I play this new deli sonification, I'm going to first replay some of the Philadelphia sonification, just so we have that basis of comparison. I probably won't let it play through the end. I'll play it for a little bit. So at some point I'll call that like dot stop function, but I'm gonna turn off my, I'll type out that Sony Philadelphia dot play with NVDA speech on, and then I'll turn it off so we can listen.
S. O. N. I. Line. P. H. I. L. A. D. E. L. P. H. I. A. Dot. P. F. A. Left, right paren.
So that's Sony underscore, oh my goodness, Alana, you are gonna knock my chair over. I'm so sorry. Okay, Sony underscore Philadelphia dot play, open and close parentheses. I'm gonna turn off NVDA speech
Speech mode off.
and hit play, or hit enter, I suppose. That audio sounds rather weak. Give me a verdict in the room, folks. Could we hear that well enough, or should I play it from the recording? It sounded a little weak on my end.
It sounded pretty okay. I think it came through pretty
Maybe
okay.
it's the. Alrighty then. All right, so just I didn't let that play the whole way through because it's pretty long, but just as our basis of comparison for the deli sonification, which will now play. I'm going to turn NVDA back
Speech
on.
mode beeps. Speech mode talk.
Alrighty, and then I'm just going to do Sony underscore deli dot play.
S. O. N. I. Line. D. E. L. H. I. Dot. P. L. A. Y. Left paren, right paren.
And we'll do the play.
Speech mode off.
Alrighty. So hopefully you could tell that the pitch in general was way higher with that new Delhi sonification than with the original and than with the Philadelphia temperature sonification. Now the pitch mapping still isn't, I don't believe, identical just based on the way that Astronify maps pitch, but this gives us a little bit more of a comparison. Now playing those two sonifications side by side, we can definitely hear that the average temperature, like in general, the temperature in Delhi is higher than the temperature in Philadelphia because the pitch is so much higher in that sonification. Now, I personally think that this sonification with the higher pitches doesn't sound as good. It's not as informative either. You can't hear like the changes between seasons as clearly. There is quite simply a reason that the Astronify team chose to map the pitches in the way they did, that those defaults are set the way they are. And it's because it generally makes a pretty good sound. I might be a little biased because I was involved in the usability testing for Astronify, but there is a reason that those defaults are the way they are. So I'm not necessarily telling you that when you have to change the pitch scaling and like the 0 point every time. I'm not telling you to do that. I'm telling you to be aware of the fact that if you are comparing two sonifications, that the scaling might be different, and that is no different from a visualization wherein for instance, a plotting sort of software like Matplotlib will scale the axes of your visualization automatically based on the points. It's something to be aware of. We need to be a little bit more aware of it in a sonification than a visualization, because visualizations generally have like axis labels where they'll have like, the upper and lower limits of the axes like written on there. We don't have like a marker in the sonification for like what the upper and lower values are. You have to sort of go and check the data yourself to do it, which is why I was sort of harping on about how we really ought to do that with our data. It's just something really to be aware of, more or less. I'm really interested in this problem of sort of axis labeling in sonification. How do we give people that information? So if you have thoughts about it, feel free to pop by office hours or to, shoot me an email. I'm always happy to chat about that. It's something I'm very interested in. But for now, I just want to make you aware of it. All right, sonification scaling, check. Any questions in the room?
In practice, how often do you have to do this like scaling tuning? Is this like something that you like listen to the sound from like multiple scales, or what's practice look like for you?
So for me personally, like when in my daily life, the honest answer is that the computer I use daily won't install Astronify. That's the honest answer. That is the most honest answer. In terms of what I expect back from, when I had a computer that ran Astronify, you might have noticed like when I opened the terminal, it says Rob. It's because I'm borrowing my friend Rob's computer. Thank you, Rob, hero of these tutorials. That sounded like sarcasm, but I mean it seriously. Anyway, back when I had a computer that ran Astronify properly, it's going to depend on a couple of things. I mean, realistically, I personally probably wouldn't fiddle with them too much, in part because I think Astronify, the way it maps things by default, does give you the best sound. And regardless, you're going to have to check sort of your maximum and minimum values anyway to sort of know where you're sitting in terms of data values. It's going to kind of depend on your goal as well. Like if your goal really is to compare two things, then yeah, you might want to fiddle around with this. But if not, might not. It's really going to depend on what your goals, what you want to do. There might be other parameters in the sonification that are more typically changed. So in our next little subsection right now, we're going to talk about an invert pitch map argument where we like flip the pitches. I'll get into that in a second. But I know that I think other usability testers found that like quite useful just regularly to sort of flip the pitches based on the use cases that Astronify is built for, which is, if you'll recall from last week, these light curves, this type of astronomical data. So it's going to be a mix of like, what are your goals and what are your preferences realistically?
Thank you.
All right, I hear silence in the room. So let's get cracking on the next bit. The only thing to do is to sonify something else.
Speech mode beeps.
No.
Speech mode talk.
Thank you. All right, next, let's sonify a very famous city's temperature. Let's sonify New York City's daily temperature. I am going to call this one Sony_NYC because I do not want to type New York City every time. Too many letters. And now Patrick can tell us whether these values are reasonable because Patrick knows. Though I've been to New York before. All right, let's do Sony_NYC.
S-O-N-I line N-Y-C.
Sony_NYC space equals space.
Space equals space.
Hopefully this is starting to get familiar. We're gonna call the Sauna series class again. We're making a new instance of it with the New York data. So remember those capital S's in Sauna series.
S-O-N-I-S-E-R-I-E-S.
Open your parentheses.
Left paren.
Type TBL for table.
T-B-L.
Hit comma.
Comma.
Space.
Space.
We want to specify our time column or time_call equals time step. Again, remembering those quotation marks around time step.
T-I-M-E line C-O-L equals tick T-I-M-E-S-T-E-P.
Close your quotation marks.
Tick.
Hit a comma.
Comma.
Hit space.
Space.
And now we want to specify our value column or val_call.
C.
Nope, not
C.
C.
Val
B.
C-O-L equals N.
Now it's trying to finish for me. Nope. Me first. Val, V-A-L.
V-A-L.
_call.
Line C-O-L.
Equals. Quotation mark, New York City temp. That's new_York_city_temp. Close quotation marks. You can see why I wanted to abbreviate it to NYC.
Tick. N. E. Double. Line. Y. O. W.
Nope, not W.
W. R. K.
New York, new_York.
Line C. I. T. Y. Line T. E. M. P. Tick. Right paren.
All right, that's Sony_NYC equals Sauna series with those capital S's. Open parentheses, TBL, comma, time_call equals, in quotation marks, time step, close quotation marks, comma, space, val_call, C-O-L, not call like phone call like column, val_call equals, open quotation marks, new_York_city_temp, close your quotation marks, close your parentheses, and hit enter.
In 34.
So we've just made a new instance of the Sauna series object for the New York City temperature. All right, next, this should be familiar. Sony_NYC.
S-O-N-I.
_NYC.
Line N-Y-C.
Dot sonify, map our values to pitches.
Dot S-O-N-I-F-Y. Star.
Nope, not star. Open and close parentheses.
Star. Left paren. Right paren.
Sony_NYC dot sonify, open and close parentheses. Again, remember we've abbreviated New York City as NYC here because I could not be bothered to type that every time.
In 35.
And then Sony_NYC.
S-O-N-I. Line N-Y-C.
Dot play.
Dot P-L-A-Y.
Open and close the parentheses.
Left paren. Right paren.
And I'll turn off NVDA speech.
Speech mode off.
And we'll hope it works again. All right, I'll stop that a little bit early. I just did that dot stop instead of dot play. But I'm wondering if anyone could hear, I'm hoping it came through on Zoom because I could hear it on my end, though it's a little subtle. Can anyone hear in there that there is this odd sort of low note, this sort of buh, 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 really low pitch note that just sort of showed up again and again, sort of at irregular intervals? Could people hear that over Zoom?
We heard it. I was wondering if that was a really cold day or something, like a sub-zero or something like that.
Yeah. So it sounds like this really low value that's like coming up again and again, and it's like kind of suspicious. Like it's the same pitch every time. That I could tell it wasn't just showing up in the winter, so it'd have to be like sub-zero in the summer. That sounds a little questionable. So let's maybe check to see whether that was just some like weird sonification effect, because I know we've had some crackling noises, things have been a little strange. So what am I going to do? I'm going to pull out that invert pitch thing that I actually just mentioned to Tony. So built into Astronify in that pitch map args thing that we used before is another option called invert, which basically flips the pitches such that now lower temperatures will be represented by high pitches and high temperatures will be represented by low pitches. Now, this made a lot of sense given the use case for Astronify, what they were trying to do with it, but it's going to be really useful for us here because I think that those really low notes are going to be easier to hear as a high little like chime, basically, than as that sort of like buh, 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 sort of in the background of our sonification. So let's invert our pitches. This line of code is going to look really similar to what we did to switch the 0 point, except instead of calling 0 point here, we're going to call invert. So it's going to be Sony_NYC. Oh, gotta turn speech back on.
Speech mode B, speech mode talk.
All right, Sony_NYC.
S-O-N-I.
_NYC.
Line, N-Y-C.
Dot pitch mapper. Again, we're calling that pitch mapper, the way we bring, the values of our data to pitch.
Dot P-I-T-C-A. Line.
Dot pitch _ mapper.
M-A-P-P-E-R.
Dot pitch map args. Dot pitch
P-I-T-C-A.
_ map.
Line. M-A-P.
_
Line.
ARGS.
A-R-G-S.
So that's Sony_NYC dot pitch _ mapper, M-A-P-P-E-R, dot pitch _ map _ args. Then open our brackets.
Left bracket.
Open our quotation marks.
Tick.
And in this case, we're calling the pitch map argument invert.
I-N-V-R-T.
That's I-N-V-E-R-T.
Tick. Right bracket.
Open and or close in your bracket and your parentheses, not in that order. Wait, what? No, close your quotation mark in your parentheses. Woo, I am struggling with these today. And we are going to set this equal to
Space equals.
space equals
Space. R-U-E.
true with a capital T. So set Sony_NYC dot pitch mapper dot pitch map args in brackets and quotation marks invert equals true with a capital T, capital T-R-U-E-E. Good grief. T-R-U-E. Set the pitch map invert argument equals true. So basically, by default, invert is false. So that means low values are low pitches. That's kind of intuitive to me. Here, we're just going to flip it around.
In 38.
And hit enter. And then we're going to sonify, Sony_NYC.
S-O-N-I.
_NYC.
Line. N-Y-C.
Dot sonify.
Dot. S-O-N-I-F-Y.
Open and close your brackets, or your parentheses, not your brackets. Whee.
Left paren. Right paren.
So Sony_NYC dot sonify, open and close those brackets and hit enter.
In 39.
So now we've remapped our values to pitches with that new invert parameter, and then Sony_NYC.
S-O-N-I. Dot. N-Y.
Oh, not dotty, so, dot. Wee.
Dot.
Sony_NYC.
Line. N-Y-C.
Dot play.
Dot. P-L-A-Y. left paren, right paren,
Open and close those parentheses. And then you can just hit enter. I'm going to turn off NVDA again.
speech mode off,
And I might stop, I might not make us listen to this whole thing. I want us to hear the notes again. And remember, we've flipped the pitches, so I would now expect those low notes, if they're not some like audio effect from the sonification, to show up as rather obvious high notes. I'll stop that early because I think we've heard quite a few of them. Those little those high notes that are in fact the same high note. So it sounds like the same pitch, kind of at random intervals to me. So again, remember that high note is low values because we've inverted the pitches. What gives? Why is that in there? What is it? Like, are there a bunch of like -10-degree days in New York City? Well, my first question is, again, like we learned last time, we didn't really check the scaling of this thing. Like maybe the whole New York City temperature column is totally just like a mess. So let's maybe like check the average temperature in New York City first to see whether that looks roughly acceptable.
speech mode beeps, speech mode talk,
Hopefully this is sort of familiar. This is going to be df
dot
new
w
underscore York.
line y-o-k
Nope.
k-r k
New York City
line
underscore city
c-i-t-y
underscore temp
line t-e-m-p
dot mean
dot m-a-n left right paren
df dot new underscore York underscore city underscore temp dot mean open and close parentheses.
out 41 55.64061521856449 in 42.
All right, so the average temperature in New York City is 55.6 degrees. That's kind of
Selected.
Whoops. Oh no. Sorry.
Unselected.
So that's what, like a degree-ish lower than the average temperature in Philadelphia. So that doesn't seem too questionable. So let me check. We know that those high notes we were hearing are low values because we flipped the pitches. So let's check the minimum temperature in this column and see what's going on.
df dot n e w.
Oh, so that's going to be df dot new underscore York underscore city underscore temp. Again, because in our data frame, this column is called New York City temp. And then it's going to be dot min, open and close parentheses.
Line o r k line c i t y line t e m p dot m i n left paren right paren out 42 minus 99.0 in 43.
Whoa, minus 99 degrees. Patrick, does it ever get down to minus 99 degrees in New York City?
Yeah. You see the bricks exploding,
So what's going on? Why are there -99s in our data? Well, what turns out is happening is that there are some days where we don't have data for the temperature in New York City. And in this particular data set, they said, well, we got to put something there. We have to put something. Well, let's just put a value that no one will think it actually gets to in New York City. Yeah, -99 degrees. No one's going to think it gets to -99 degrees. That's fine. Just fill all the empty spaces with -99. But Astronify has no way of knowing that the people in this that made this data set were like missing value, -99. So it just goes on its merry way and sonifies it, which is why we're hearing this sort of repeated identical tone. It's because every time there's a missing data point, it is sonifying it as if it's real data. Now, in the spirit of complete transparency, all of these columns originally had missing data. And for the columns, we have already sonified here so that we'd have something nice and clean to work with. I basically replaced those missing values with a method that we call linear interpolation. I am not going to get into that right now. If you're curious about how I sort of pre-process the data to make it usable for us here, feel free to reach out to me and I'll sort of just fling the .py script I use at you and you can take a look at it. But you'll often find in real data that we have missing values. This is sort of like a fact of life when you work with data, that there's going to be missing values. Sometimes it'll be filled with some impossible numbers so that you can easily identify, that's not real data, as they've done here. But sometimes what you'll see in data science, especially in Python, is you'll see missing values filled in as something we call an NaN, or you'll sometimes hear people call it nons or nans. I call them nons. My office mates make fun of me because they call them nans, but they're NaNs, or more accurately, a NumPy NaN frequently, but Pandas has its own version too. What is this NaN thing? It stands for not a number. And so often if you have like a blank space in a data frame, it will just get parsed as a NaN, a NaN, as a not a number. There's not a number there. Now, a lot of functions, especially like Pandas and NumPy functions, are sort of accustomed to these NaN things, these missing value placeholders, and we'll sort of ignore them in the way you'd hope. But sometimes they will wreak havoc on some functions, and then you'll spend forever like hunting through your data. Where's the missing value? Where is it? Oh my goodness. Fortunately, there's a really quick and easy way to check whether or not our data has an NaN, a not a number, this like not an actual number value in it. And that is with the NumPy isNon or isNan, is NaN function. So if we do NumPy
N-U-M-P-Y
dot is
dot I-S
NaN,
N-A-N,
so all one word, NumPy dot is NaN, open your parentheses,
left paren,
df
D-F
dot New York City, df dot new underscore York underscore city underscore temp. So calling that column of df with the New York City temperatures in it.
dot N-E-W line Y-O-R-K line C-I-T-Y line T-E-M-P right paren.
So that should read numpy dot is NaN, open parenthesis, df dot new underscore York underscore city underscore temp, close parentheses. So basically, please numpy, check if there are nons in this column of the data frame and hit enter.
Out 43, 0 false, 1 false, 2 false, 3 false, 4 false, 9,260 false, 9,261 false, 9,200.
All right, I'm not gonna let it finish, but what gives? That's a lot of falses. Well, what it's doing is it's giving us an array, like a big old chunk of values. What we remember learning from Patrick are Booleans, so true or false values. It has the exact same shape as this column. So we said, hey, check if this column has nans, and it's returning a Boolean array of the same shape as the column we asked it to check, where it says false at any location where there is not a nan, so this is not a number, and if there is a position where there is a nan in that data frame or that column we had it check, it will return true. Okay, but I don't know about you, but I do not want to read 9,265 rows of falses to check whether there's a single true in there. That sounds horrendous. What will we do instead? We're going to call the .any function. So if we type that exact same line that we just did and then tack a .any open and close parentheses at the end, that'll tell us whether there is a single true value in that array. So basically, even if 900 or 9,264 of those values are false and one of them is true, then .any will return true. So basically say, are there literally any NaN values in here? So that's going to be numpy
N U M P Y
.isNon,
dot I S N A N
open your parentheses,
left paren
df
D F
.new underscore York underscore city underscore temp
dot N E W line Y O R K line C I T Y line T E M P right paren
All
dot
right.
any
And Miss trying to tell me, yes, you want to do .any, and it's right this time. numpy.isNon, open parentheses, df.new underscore York underscore city underscore temp, close parentheses, and then add at the end .any.
dot A N Y left paren right paren
And open and close those parentheses, leave them empty, and hit enter.
out 44 false in
Out.
45
Out, false. There is not a single true value in the return of that isNon function, which means there are no NaNs, no not numbers in this array. That's a good thing, because if there were missing values and they were at random filling some with negative 99.0 and others with NaN, I would be upset. That would be messy. But it's when dealing with real data, it's good to know the different formats you could get these sort of missing values as. So we've checked now, there are no NaNs in our data, good to know, but we have these missing values, these negative 99.0s. What if I do not want those little chimes in my data? What if I say, that's very annoying, please get rid of them? Well, fortunately, actually, this is going to be the last bit we cover in this tutorial. So before I do this last bit, would anyone like to ask questions? I get ahead of myself. Any questions repeatedly coming up, or otherwise we will hurtle through the last section of the tutorial. I'm hearing silence, so let us get a move on. All right, let's do this last portion. All right, so as I said, what if we don't want those little chimes for those negative 99s in the data that are just sort of there? What do we do? Well, fortunately, another pitch map argument that they call min-max percent allows us to sort of clip outermost values from from the values we're sonifying from the sonification. So for instance, suppose I set the min-max percent equal to 5,95. That means that the 5% lowest values in the data are going to be excluded from the sonification, and the 5% highest percent of the data, so the 5% greatest values, are also going to be chopped out of the sonification. Do not include them, get rid of those, we do not want them here, cut them out, they are extraneous values. So we can just chop out, we know these are really low values, chop out, the lowest some percent of our data, get rid of them, don't include them in the sonification, please, Astronify, get rid of them, and then re-sonify the thing. So let's get into that. It's going to look, again, very similar to when we changed that invert equals true. It's also going to look very similar to when we changed that 0 point. It's going to be Soni underscore NYC.
SONI line
NYC.
NYC
Dot pitch mapper.
dot PI itch T C H line MAP PER
Soni underscore NYC dot pitch underscore mapper dot pitch
dot PITCH
underscore map
line MAP
underscore args
line, A, R, G, S,
Open your brackets,
left bracket,
open your quotation marks,
tick,
and this one is called min,
M, I, N,
max,
M, A, X,
all one word, underscore,
line,
percent.
P, E, R, C, E, N, T,
Close your quotation marks,
tick,
close your brackets.
right bracket,
So that is Sony underscore NYC dot pitch underscore mapper dot pitch underscore map underscore args, ARGS. Open your brackets, open your quotation marks, min, MIN, max, MAX, underscore percent. Close your quotation marks, close your brackets, hit space,
space,
hit equals,
equals, space,
and then this is going to be equal to a list type object. So we're going to make a list. It's going to have two numbers in it, our lower bound and our upper bound. Now I'm going to make our lower, and I'm going to put this in brackets because it's a list.
left bracket,
So open our brackets. I'm going to make our lower bound 5.
5,
What does that mean? It means chop out the 5%, like the lowest 5% of our data, because I think that should chop out those negative 99s for us. Now, there is also a min-max value where you could cut out at exact values. There's in the curriculum, there's a description of the Astronify parameters that talks about this in detail. I tested it. I liked the way min-max percent sounded a little better, so we're going to stick with that. So that's going to be equals open bracket 5 to cut out the 5% lowest data, 5 comma,
space,
because we want to specify the upper limit. And I'm not concerned about the upper limit here because the missing values are negative 99s. We probably, for the sake of completeness here, really should have checked the maximum value in the New York City temperature column, you know, to make sure there was nothing really funky going on there. But for now, take my word for it. The missing values are those low numbers. Also, again, it would be chaos if they had missing values and filled them with like negative 99 and like 1,000. That would be incredibly rude of them. If you ever make a data set, don't do that. That's horrible. Okay, so then I'll do 5 comma space 100.
1, 0, 0,
So basically that means go up to the 100th percentile, go up to the maximum value of the data. Don't cut off anything at the upper end.
right bracket, in 46,
All right, so we've changed the min-max percent. Again, that's going to be Sony underscore NYC dot pitch mapper dot pitch map args with pitch underscore map underscore args. Open your brackets, open your quotation marks, min-max percent with an underscore between min-max and percent, close quotations, close brackets, equals, open brackets, 5, comma, space, 100, close your brackets, hit enter. Again, we're just chopping off the 5% lowest data out of our sonification. Hit enter. All right, again, we need to remap the data to pitch. So that's Sony underscore NYC dot sonify.
S, O, N, I, line,
Sony underscore NYC
N, Y, C,
dot sonify.
dot, S, O, N, I, F, Y,
Open and close your parentheses.
left paren, right paren, in 47,
And then Sony underscore NYC dot play.
S, O, N, I, line, N, Y, C, dot, P, L, A, Y, left paren, right paren,
And remember, before I hit play here, before I hit enter on Sony underscore NYC dot play, recall that we have still inverted the pitches. We haven't changed invert equals false. So just keep in mind here that higher pitches are still representing lower temperatures. That's okay here because I think what we're interested in is hearing whether those notes are sort of cut out. And I think they're, at least for me, they're easier to hear as higher pitches. Maybe for you, they were easier to hear as lower pitches, but just keep that in mind that we haven't changed that argument. So it's still there. All right, let's hit play. Oh, let me turn off NVDA's speech.
speech mode off,
All right, here we go. All right, I've stopped that, but mostly, even though I hear some like sort of high pitched, like almost kind of squeaky noises that aren't super pleasant, they're not those individual notes that are like those bing, boom, boom. So I'm not hearing anymore those really high pitched single notes at the same pitch at sort of random intervals. Sounds better to me. Though again, feel free to play around with the min-max percent, like where you put that cutoff if you're interested. That concludes our discussion on missing values, and also looking at the time, it concludes our discussion, our tutorial for today, because it's 8 p.m. I will say there's even more material available online for the curriculum, some model testing. So if you're curious about that, I highly encourage you to go check that out. There's also discussion of Astronify's different arguments. I just figured I'd rather provide more material online than we could get through, because you know, I'd rather you guys have more to work with than less. So if you're curious to go through a little more, there's more online on the curriculum, which was sent in the email today. And I'm happy to stick around and answer questions, anything like that. I'll leave my screen sharing for the moment in case there are any coding questions before we wrap up. All right, I'm going to stop sharing screen then, because I'm not hearing coding questions. I'm hearing silence. And then I'll turn my camera back on. Wow, I'm here again. All right.
Well, I'd just like to say thank you, Sarah, for walking us through both last week and this week, and for introducing us to this idea of sonification. I guess I do have a question for you, and I'll first just, say, we're at time. So if anyone wants to hop off the call, maybe have another meeting or something like that, maybe you want to eat dinner, then I'll just say a quick thank you for joining us, and thank you for spending time learning some of these non-visual data science techniques. But Sarah, I did have a question, which I guess is, maybe you could give us your opinion on the state of sonification, or making sonifications, and like if you think things are going to get a little more stable or a little more interesting in the next couple of years. Like, what's next for sonification?
Yeah, okay, this is a really interesting question, and it's a tough one to answer. I think, at least within astronomy, which is where I'm most familiar, there's a lot of interest in sonification. There's kind of been like an explosion of sonification, sort of outreach things and softwares to do things. And inherently with interest comes improvement. However, another necessary thing for improvement is like community cohesion and money. And so there has to be, I think you've talked about like these project grants that you would love to see from other, organizations. Like there needs to be like some money put into these things so that people have like the funding to sort of make things more stable and also make things more standardized. I've taught you how to use Astronify here, but a different sonification software might sonify things entirely differently. So I would say in terms of I think of sonifications in roughly two aspects, sort of these like beautiful outreach sonifications. That's kind of like the universe of sound sonification that I played for you last week, where it was like that galactic center sonification. I think those are in really good shape. People really like those. People's responses to those are really high. They're really great for outreach and community engagement, including among the blind low vision community. Things look good for outreach. For the more technical sonifications, such as Astronify, which are meant for doing research, doing science, I think that's when things get a little more shaky. I think things get, a little more experimental. But again, I think with more interest in these things comes more improvement. I've talked to I've talked to people who are interested in working on these things. I think part of the problem is, again, a lot of the funding for sonification is still in this outreach realm, which helps get that moving quicker, just in what I've seen. And you know, I don't have all of the answers. I think things are going to get better inherently just because there are people interested. How quickly, I don't know. That said, I do know, and you also know, the people at Space Telescope Science Institute who make Astronify, and they are awesome. Cannot say enough good things about them. So if there are problems with Astronify in particular, do, like, you know, reach out to them, submit something on GitHub. Their email is on, like, there's an email on the Astronify website, which is linked in the curriculum. Like, get in touch with them. They're wonderful people. Realistically, I actually probably should have reached out to them to ask about the whole Mac install issue, which maybe I still could do and update everyone. But on the
create a new tool.
Astronify in particular front, they're wonderful. So yeah.
Yeah, Scott is very nice. Thank you,
Yeah.
Sarah. And I would say, just to add to that, I mean, I think that it's kind of the non-fun parts of making these libraries is kind of the issue, you know, which is making sure that the sound is compatible across every OS, and then also maybe that there's like fallbacks if, you know, if it's not creating, you know, so then that's not really the fun kind of programming. That's kind of the kind of programming programmers didn't exist. So I think that does definitely requires to pay somebody to sit and test and run it on a lot of different OSs, and even getting your hands on a bunch of different computers kind of costs money. So, but yeah, I'm hoping that it does. We do get a nice stable library, or maybe it's going to be Astronify. Cool. Anyone else have any questions for Sarah? I think maybe that's a hand raise. So if you want to hop on the mic, I can't tell who it is, but
Is that Rosanna? Rosanna?
Oh, the audio now unmuted.
It is.
hey, Rosanna.
I had asked this in the chat, but I had to leave, so I didn't get the answer if it was given. But can you remind me when these office hours are, and if they're the same link as what I got on, as what this was?
The same link, and they are going to be on now on Thursday at the same time of day as this tutorial. So that's 1 p.m. Eastern time, 6 p.m. GMT, Thursday. And then that will be the last office hours, sadly.
Mhm.
But,
Yeah,
you know,
I
we
wanna
will
try
always be
one.
available by email.
Okay. Because I want to try it. I don't know why, but when I did it with last week, following your instructions for last week, it did not play the sound for me.
Did it not? Did it play this
No.
week? Not this week either.
Well, I didn't. I wasn't able to follow along this week.
I
just
see.
did
Okay.
it after the fact last week.
Huh. All right. Well, are you on a Windows computer?
Yes.
All right, let's go through. Yeah, do try to come to office hours on Thursday and we can troubleshoot together, or send me an email and we'll take a look together. Yeah, sometimes the terminal's a little laggy with Astronify. That's my first guess at, you know, it might be like this, like, turn it off and on again sort of issue, which is annoying, but that would be my first guess. But yeah, we can diagnose it together.
Mm-hmm. Another one that I'd like to try is I've been on a weight loss program, and I've been keeping track of my weight, you know, every week. I want to try to
Yeah.
make a sonification with that.
That's cool.
This would be a perfect thing for that, actually. Yeah, because it's that sort of value versus time. That works really well for Astronify. So yeah, give it a try. You just sort of have to dump it in like a, well, you have to dump it in a, for our purposes, a data frame first, and then make that into an AstroPy table to give to Astronify. But yeah, should be relatively straightforward.
Yeah, this type of thing is just down my alley. I love this kind of
Perfect.
stuff.
Me too.
Thanks a lot.
Glad you
Oh,
enjoyed
thank
it.
you for
Appreciate
coming.
it.
Thank you, Rosanna. Does anyone else have any questions for Sarah while we have her?
You are unmuted.
Hi, I do have a question. Hello,
Hello.
this is Laura.
Hi, Laura.
Laura.
Like,
Hi, go ahead.
oh, I was just gonna ask what your question is.
No, I was just asking, are you gonna have any more classes coming up, any more series?
Well, I will say that we're not really a school, we're a consultancy, right? So maybe there's an
Yes.
opportunity to talk a little bit about IOTA just briefly at the end of everything. Again, we are a small consultancy where we work on technology, including web technologies, curriculum development, and very kinds of writing. So really, what I like to do is partner with an organization. In this case, I thought that this should exist. So I went to Pandas. I thought they would be a good partner. And I asked them, would you work with us to create something for this community? And they said yes, which was really amazing. But it's very helpful to have advocates out there because I do work with cool people like Sarah, and a couple of other blind folks like Krishna and people like Tony, who are my colleagues. But really, what we need is a little more surface area to. If you thought this was a good, we do I love to make curriculum. I love to teach people stuff. If you thought this was useful, send an email to, whatever blindness organization you're closest to. Or other organization that you think might have resources to kind of put behind this. And the reality is, I used to do a lot of this kind of work, and then I just put it on the internet and do it for free for people. And that's what I always try to do. But I also have a little baby at home here now, and I do need to try to partner with people to bring in some funding to do this kind of work. And it's very time consuming. To put together these kinds of workshops, so if you have any ideas about organizations to put me in touch with, or to tell them to reach out to me, or you could propose it yourself and just say loop me in later. That's what we do. So and I guess the answer is maybe, hopefully, and we will try to have more
Thank you
work
very
like this.
much.
Cheers, Laura.
Thank you. And I reached out also, so maybe
Excellent.
we
I
can
think I
communicate.
have an email from you, and I just haven't responded to it yet.
No problem. No problem. I understand.
And I
There
remember
you
it
very
was a
much.
very
lots of
kind
emails
email.
coming in.
It's a very kind email, and your email was a little longer, so I wanted to do a more substantial reply, and I just haven't
No problem.
gotten back yet.
I
But
totally understand. And it's been very useful, especially for me coming from data science. I wish I knew this before. Like I had this series before I went to data science, especially since I'm blind. It's just made everything so much easier for me.
you did a master's, correct? I
Every-
think I'm remembering yeah. I know it's
Yes,
very
I appreciate it.
and I think you had a common experience, which is an experience I had doing my PhD too, which is, if you don't mind me saying, I'm sorry, that we blind and VI folks were often wind up spending more time on accessibility than on the thing that we're actually doing, which is fine. And then everyone calls us advocates and so on. But then really, sometimes we actually just want to do the work that we signed up to do. So it can be a little frustrating, right? And things can take a long time. It took me a long time to finish my PhD, and that's reality. But I guess hopefully generate. I was just talking to another blind, technologist, Josh Mealy, and I think he's at Amazon now. But he basically said, well, when I was younger, there was no such thing as a screen reader. So you know what I mean. So I think things are. It doesn't almost feel like it, but maybe things are improving. It's just a little slower than we want.
Thank you.
Yeah, thank you. And also, I will say, if we're talking about this with some others, but basically, if you are the only if you're a person in your community, you've joined these workshops, and you feel like you've gotten something out of it, maybe you've learned a few things, and you're practicing on your own. Feel free to use these materials to teach your own workshops. I have to talk to the Pandas folks about what license they want to release these under, but it's an open source project. I have to imagine if it's remotely possible, I will release these under a Creative Commons license. and I encourage you to use them to teach. If you want to lead workshops for your own community on these same materials, I very much encourage you to. You don't have to ask for permission, though. I would love to hear about any work you do with these materials. And you can build on them too if we do manage to put the Creative Commons license on it, which you'll see an update on that in the repository if we manage to do that. So, okay. I mean, anyone else have something for Sarah?
You are muted.
I have, this is Tim, and I have just it's a more general question. These classes have been really, really good. If I want to learn more about data science, pandas, Astronify, are there particularly good sources to go look at to learn more, to dig deeper into these topics?
That sounds like maybe a Sarah question. Sonification specific or data science in general?
You are muted.
Both, actually.
Well, I'll give my answer, and then maybe Sarah will be able to jump in. I would say it's a little bit difficult to answer that question for data science in particular, just because I think there are limited materials specifically for the visually impaired. I would say one avenue is to try to get good at Python and whatever environment you choose to use, whether it be VS Code, IPython. So I would recommend joining some blindness related mailing lists. I have an issue for this, but I will be putting in a resources page on the in the curriculum. I haven't actually finished it yet. I started it, but I haven't finished it. But there are good mailing lists like Python Viz and Program L, I think is what it's called, which are very active mailing lists for Python and visually impaired programming in general. And I am going to, I've just paid for it or whatever, and the server got set up and everything. So we should have in the next day or two a new mailing list for data science. Unfortunately, it does feel like very 1990s with these technical blindness communities, in terms of it's very mailing list driven. I do think there's space here for that we should have more resources online, centralized and books and so on. But it feels like very early days. So I'm hoping we'll have more of that soon. I'm hoping to put this online as a resource, and I would love to turn it into something resembling a book in the coming months and years, but we'll see. But yeah, there's not a lot out there just for us VI folks. And I learned a lot of this mainly by first I learned Python with a book called Learn Python the Hard Way. This is a long time ago, maybe 9 or 10 years ago, or maybe even more. And then a few years ago, I got more into data science, and I really just sat with a lot of blogs and tutorials and stuff. And I didn't find that there were that many books that I found super helpful for the data science specifically. So it was kind of a lot of just trying to do things and then looking up how to do them. Sarah, maybe you have a more encouraging answer.
Oh, I mean, I think this is very much like the researcher way to learn to code. Like I took one coding class in undergrad that almost fortunately went on Zoom partway through because that made it much easier for me to follow because everything was online instead of like them typing on a screen. So it was almost easier that way. But and then it was really just like, oh, I need to do this thing for research. Well, I better Google and figure it out. And that's more or less how I learned to code, just Google and discover, which is not super helpful here, I know. But yeah, maybe if we do put together a resource list. As far as learning sonification, there are some things I can recommend. First of all, for more like outreachy type talk, the astronomer Wanda Diaz Merced, who's a blind astronomer, gave a TED talk about sonification. I think if you Google like blind astronomer, like blind astronomer TED talk, that'll come up. And I think that was one of my first introductions to sonification. I've also linked on the curriculum. I should have linked both the Astronify webpage, which is all their documentation, and then also Dr. Scott Fleming from the Space Telescope Science Institute. He's the project lead on Astronify. His talk about Astronify at the Space Telescope Science Institute Day of Accessibility. That's another great thing to check out. If you send me an email and want to know more, I'm happy to dig up some more resources for you. And then if you really want to dive like into the deep end of sonification, there's a Sonification World Chat. It used to be every month, now it's maybe every couple months-ish. that's on Zoom with like sonification researchers from all over the world. And I could, if you reach out to me, I could see about getting you added to that group as well. If you're really interested, though, that one tends to be a little bit more technical on the research side as opposed to like the using sonification side. So that's my little spiel there.
And with that, Tim, thank you, Tim, if I'm getting your name correct. And let me just give a little, I'm gonna probably end the recording now in a minute, but I just want to give people kind of a few like words of encouragement, I think, for here. And basically I just want to say, first of all, you know, the usual that we're VI folks, we're blind VI folks. This is definitely an area where, you know, the tooling could be, you know, that, you know, we've used some tools here that are definitely usable, and you can get a lot done. And I would say you can do most things, but it is harder. It takes a lot of us more time to learn it. And also we don't have access to some of the same approaches that our sighted colleagues would. With that said, I think that, you know, we're having a little bit of a moment for this stuff, that people are really working on this. There are organizations that are becoming more interested in it. And I would also say, if you can manage to develop a little bit of your Python skills, if you can manage to develop a little bit of your data science skills, then it is a useful moment you could really make a difference in terms of the tools that are available to people, the curriculum and the resources that are available to people, or even if you wind up teaching using some of the resources we've created and so on, then that could really make a difference for other people. So it's, you know, it's a difficult area, but I do think things are moving. I think it's a good time to get involved. I also think it's an area that makes sense for blind folks. There's no reason we can't do data science. It's a very non-visual medium when you actually get down to it and when you actually learn how things work. So I'll say that, and I'll also say, you know, I'm trying to activate some folks who, you know, maybe they have resources, maybe they're organizations and so on, and also to create some resources. So I'll be creating this mailing list. I have a website up called blindcoders.com. It basically has nothing on it, but we will, you know, I'll put this on it. I'm going to put this up there if I can, or at least link it if Pandas wants to host it. I'm going to link to other projects that I know about. If the mailing list is active, if people get involved, I will try to build that out. I'll try to maybe we'll add forums, maybe we'll add other resources, maybe we'll add, you know, whatever. Maybe we'll try to host other people to write some curriculum and do some workshops like this. And I'll say, you know, stick with it. Like, hopefully this provides you some basis for learning. Check out the book. Once I send out the resources, check out the other resources for learning. And you know, I think that you can really actually, you know, it may be discouraging, you know, you do a few days of it and you're like, this is really hard. But if you stick with it for a year, you stick with it for 2 years, people always overestimate what they think they can do in a day, but they underestimate what they can do in a year. In a year, if you stick with stuff like this, you'll be a programmer, you know what I mean? And people get hired and so on after doing only a year or two of learning how to program. And I've already seen some of you, like people like Nick Hill, you know, they've been doing contributions. Nickel did his first GitHub open source contribution on GitHub that I saw during this. And that's very encouraging to see. And there's a lot of meetings and so on you can jump on. There's the Jupyter accessibility meetings that meet I think monthly or something like that. There are the Sonification world chat. These are open source as a culture where you should just speak up, jump in, create issues, create pull requests that are basically suggestions for how things should be, and also open meetings. So, and you're allowed to speak up, you're allowed to participate. You know, I think we're often encouraged to be in the shadows and be you know, not speak up as blind folk, but I think, you know, we need to. So, okay. So thank you very much. I really appreciate you all making this such an amazing, energetic workshop. We had over 350 people sign up for these workshops. We had some of the workshops, they had 50, 70, 80 people in them. There's tons of people following at home. People are sending updates. People are translating the curriculum. I'm feeling a lot of energy with this, and I hope to keep it up. I hope to create more resources for you all. So thank you very much.